So if you remember from last class, we were looking at functions and relations, and then we also started class with what was called set notation and interval notation. We're using interval notation today to decide domain and range of functions. So let's go ahead and take a look at graphs and start with the domain. When we are naming the domain, we are naming every x value that's represented by that graph. So if you notice on number 1, there's a lot of ordered pairs. There's an infinite amount of ordered pairs that's represented on that graph. And we technically would have to list every x value. We know that's impossible. We can't list out every single one of those numbers. So that's why we use interval notation. So anytime we're deciding on domain, we always go smaller number, comma, bigger number. So we're going from left to right to go smaller to bigger. Going off to the left, notice this graph goes to the left forever. It also goes to the right forever. There's no holes or breaks in that graph of any kind. So the domain on this one is actually negative infinity to infinity. Infinities always get parentheses. Looking at number 2, this graph is also going to the left forever. It's going to the right forever. No breaks or holes in that graph either. Therefore, it's also negative infinity to infinity. Number 3, however, does not go to the left forever. It starts at this x value of 3 and goes to the right forever. So because we're starting at 3, we want to include that value of 3 because it's part of the graph. It gets a bracket, goes off to infinity with a parentheses on the end. Looking at number 4, number 4 also does not go left and right forever. It's actually starting at negative 2, x value of negative 2, and going all the way to the x value of 5. So we're going to start at negative 2. Negative 2 is part of the graph, so it gets a bracket. We go to 5. 5 is also part of that graph, so it also gets a bracket. Take a look at number 5. Number 5 has a break in the graph. This dotted line, you might remember from Algebra 2, is called a vertical asymptote. There's no graph on that vertical asymptote, so we have a graph on the left side. We have a graph on the right side. It breaks it up into 2 parts, which means we're going to have 2 intervals. Let's look at the first interval, this part of the graph, the left side of that asymptote. It's going to the left forever and ever and ever. We know that's negative infinity. Then it goes all the way up to 4. It's going to get closer and closer to this x value of 4, but never touch it. So that 4 is not part of that answer, so we're going to put a parentheses on the 4. Then it jumps over that asymptote at 4, and on the right side it does get closer and closer to 4 on the right side, but then it also goes off to infinity. So we're going to have 4 to infinity. Notice 4 is not part of the graph. Both of those 4's get a parentheses. Let's look at number 6. On number 6 you have a point at negative 2, and on the other end you have an arrow. That arrow is telling you you're going to the left forever and ever, and then it comes all the way up to this x value of negative 2. We again have 2 parts, so we're going to have 2 intervals to represent that. That first one is negative infinity to negative 2. Negative 2 is part of the graph. It gets a bracket. We got to jump over to the other side. It starts at 2, and then it goes off to infinity. So we have a bracket, 2, comma, infinity, parentheses. Remember, we put this union symbol in the middle. It doesn't have the tail on it. So there are our domains. We're going to now take a look at the range of these exact same graphs. Let's look at the range. Range, we know, are our y values. Our y values start from the bottom of a graph and go up on the graph if we're wanting our smallest y values to our biggest y values. So we're always going bottom to top on these. As this graph goes down, it's going down forever and ever and ever. As it goes up forever and ever. So this range was, again, negative infinity to infinity. Let's look at number 2. Number 2 doesn't go down forever. It's starting at this y value of negative 2 and going up forever. So we're going to have a negative 2 with a bracket because it's part of the graph. And it goes up forever and ever. That takes you off to infinity. Number 3, we're starting here at this x value of 3 and going up forever and ever. Now, you have to be careful. We don't want to name this with the x value. What's the y value at that point? So remember, if it's on the x-axis, It's a number, comma, 0. So really that point is 3, comma, 0. We got to use the 0, the y value, and then it goes off to infinity. Because 0 is included, it gets a bracket. Looking at number 4, bottom to top, your first y value is here again on the x-axis. You have 2 of them, and that's okay. But what are the y values at both of them? They're both 0. So we're actually starting at 0 and going all the way up to our y value of 3. Both 0 and 3 are part of the graph, so they both get a bracket. Number 5, this graph is going down forever and ever, and then it comes up and it levels out underneath that x-axis but doesn't touch it, which means it doesn't include a y value of 0. It's everything below, but it doesn't include 0. Then it jumps over, and this gets closer and closer on this side, and then it goes up forever. So we've got to write 2 intervals, one for this lower half, and then one for the bigger half, the top half. So this one goes negative infinity up to 0, but doesn't touch 0, so 0 gets a parentheses. Then the second part starts at 0, again doesn't touch it, and then goes off to infinity. Notice we use the little union symbol again to show that those are both part of our solutions. Looking at number 6, our smallest y value starts here at 0. Both of those have a y value of 0. And then they go up forever and ever and ever. So that's bracket 0, comma, infinity. So that's looking at a picture. What if we don't have a picture? Well, sometimes we just look at the functions themselves. And if you think about the different functions that you've already dealt with in Algebra 2 and Algebra 1, you wrote equations of lines all the time. And if you think about your equations of lines, they always go left and right forever. They always go down and up forever. So the domain for those lines are always negative infinity to infinity. What about parabolas? We know parabolas go left and right forever. Remember, a parabola has that U-shaped graph? So lines kind of look like this. They go left and right forever. Parabolas also go left and right forever because they have that U-shaped curve. Absolute values, remember, look like a V. They also go left and right forever. No breaks or holes in those graphs. Many of our polynomial functions also had a domain of negative infinity to infinity. Remember, those are those smooth graphs that kind of look like roller coasters. They've got lots of hills and valleys in them. Second semester, we'll look at the sine and cosine function. The sine and cosine function kind of has a lot of hills and valleys as well. They go up and down. They oscillate back and forth. Those also have a domain of negative infinity to infinity. So looking at this list, you're going to notice there are a lot of functions that have a domain of all real numbers. We really have 2 troublemakers that do not give us a domain of all real numbers. Those 2 troublemakers are whenever we're trying to divide by 0 or we're trying to take the even root of a negative number. So most of the time the domain is all real numbers. However, if we end up with a fraction where we can't divide by 0, or if we end up with a radical that has an even root, we can't take the even root of a negative number. So when we look at a function, we're going to decide, do we have a fraction or do we have a radical with an even index? If the answer is no, then our domain is going to be all real numbers. If our answer is yes, then we've got to troubleshoot our 2 troublemakers. So here's our troublemaker number 1. It's a fraction. So how do we find the domain of a fraction? Well, we said we can't have the denominator of a fraction equal 0 because we can't take 3 divided by 0. It would give us an undefined answer. So we would take that x minus 1 and we're going to set it equal to 0 and figure out what that number is. Really, our domain is going to be every number except that one. So you can say I said not equal to. So this is actually finding our domain. We saw for x like normal, move that 1 over to the other side by adding it. So our domain is every number except for x equals 1. So how can we write that out? So if we're thinking about a number line real quick, I don't know, I might already have one sketch there. We're looking at our x value of 1. 1 can't be part of our answer, so it would be an open circle there. But we would shade everything to the left and everything to the right. So we would write that in interval notation. Our answer would be negative infinity to 1, union 1 to infinity with parentheses on all ends. Let's look at number 2. Number 2, notice I already factored that denominator. I'm going to set both factors where it can't equal 0, because those are numbers that can't be part of our domain. We solve for x like normal. Once you solve for x, you get those on your number line. Notice we would have every number but these two values. So we'd have all the numbers left of -5, all the numbers in between -5 and 2, and everything to the right of 2. Do you see you have 3 pieces? 3 pieces mean we have to write 3 intervals. So the first interval goes negative infinity to -5. The second piece goes -5 to 2. The third piece goes 2 to infinity. We would have to put parentheses on all those ends because we are not including the -5, the 2, or the infinities. So troublemaker number 1 is if you have a fraction, you take the denominator, you might have to factor it first, set it equal to 0, and those are the numbers that can't be part of the domain. Everything else is part of the domain. Look at our troublemaker number 2. It's our radicals that have even indexes. So we know we can't take the square root of a negative number. It gives us imaginary values. We don't want imaginary values. So we have to try to make sure that whatever's underneath this radical always stays positive. So if you want x plus 5 positive, you really want it greater than 0. It's okay that you can take the square root of 0. Square root of 0 is 0. So we actually are always going to take whatever's underneath that radicand and set it greater than or equal to 0. Solve for x like normal. We've got our domain being x values greater than or equal to -5. This is telling you your domain. Let's go ahead and take a look at that in interval notation. Because it's greater than or equal to, we want to include the -5, and greater than means it goes off to the right, so that goes off to infinity. So, looking at our picture here, we would start at -5, we would go off to the right. You can use your graphing calculator to make that sketch. So you'd put it in your y sub 1, your function right there, and then you would see this picture. Now, whenever you want to know the range, so far we've only talked domain, we know that we're starting our x value of -5. We need to know the y value at that spot. So if you plug -5 in here in the x spot, -5 plus 5 makes 0, square root of 0 is 0. That told you this ordered pair was at -5, 0. So we're starting at 0, going up forever and ever. Your range would be 0 to infinity, including 0. Let's look at the last one. Again, we don't want the radicand, the 3x minus 7, to be a negative number. So it's going to have to be set greater than or equal to 0 because we don't want it negative. It's greater than or equal to, solve for x, just like you normally would, and then you get x is greater than or equal to 7/3. So for our domain, we're starting at 7/3 and we're going off to the right forever. So that gives us 7/3, infinity, bracket on that 7/3. What about the range on that one? Again, you could plug the 7/3 in. 3 times 7/3 is 7. 7 minus 7 is 0. Square root of 0 is 0. So that put us at the ordered pair 7/3, 0. Our range going bottom to top, 0 to infinity, including 0. Now, the range isn't always starting at 0. It was just happening that way on these two examples. But again, you could type that in your calculator and look at it. That's all I have for today. Have a good one.